All right. So yeah, so we're actually going to talk about, was it section 24? Numbers all mess me up. But basically data generation in Monte Carlo and resampling. And then we'll get into hopefully improving linear regression a little bit later if we have enough time. But first thing we're going to do is let me go to start sharing my screen. And then Eric, I think your computer fan might be a little loud. If you mind.
Yeah.
Okay, cool. Thank you. Yeah, that's much better. Cool. So, okay, see my screen here. So again, I think I mentioned this. I can't remember, Eric, if I mentioned this before. It's on GitHub, but I restructured the format. So now it's, if I look this closely like this, you'll see that instead of having by module, I broke it up by subject, by topic. So right now we're going to talk about data engineering, and then we're going to go into statistical modeling. So this way it's a little bit easier to find for version 2 because we kind of have that little difference in curriculum. So just be aware of that. But okay, so let's talk about data generation then. So data generation is kind of an interesting aspect that we can do. So I can make this smaller. Here we go. So data generation is really useful to like test out our models. And so we'll, especially later on, coming up, we're going to do a lot more machine learning models in this module 4 section. And one thing we want to do before we actually be able to use these models, actually be able to test them out and say, are they useful? Are they actually getting the things we want? And this is where data generation is really useful, because sometimes you might have a machine learning model and you have your data already, but you're like, I don't know if let's say in the future, do you apply your model to future data? You might not have enough data to actually test this out. You want to see, well, what if the data looks a little different? Like, will this model work well? So we can actually generate data to help us make it useful for us to test. So one thing we can do also, we have to be careful, is that we can't just generate the same data. Like, for example, if you make the data too perfect, for example, you don't want to make your numbers all integers, because obviously your integers, like that's almost too perfect. You want a little bit of randomness in your data set because real life data is not perfect. So here's a little link to scikit-learn's. We'll see this again in clustering, but you can see here is in the column here, is a certain kind of application, different techniques for clustering algorithms. Not important exactly what that is, but the important part is to know that these are different techniques. And on the rows here are basically different data sets. And you can see these data sets look very different from each other. And you can see here is that this color is basically classifying. So you want basically the shapes to be similar colors. So for example, in this circle right here, you want the inner circle to be a different color from the outer circle, because that's the actual pattern. And you can see different algorithms, different techniques do different jobs. So you can see that these middle ones do a really good job, but this one over here, these ones over here don't do a great job of detecting the right kind of pattern. And here you can see these other shapes here too. You can see most of these algorithms do a really good job, maybe except for this one right here and this one, detecting the correct pattern that you would expect. And you can see here there's a bunch of noise essentially. And you can see here that there's a really good job at detecting noise, and these ones are trying to find patterns that don't exist. You can see basically like looking at this part, you wouldn't see a pattern, but these ones, these different clusters you would expect. So, excuse me, these are ways to generate different data sets that look differently to help test your different models out. Okay, so we'll see actually how to generate these data sets. So what's nice is that we can actually use scikit-learn. And this, I think part of this is actually directly from the curriculum too. So know that this little modification. But here, basically, I'm going to show you some example of like what this data will look like. So what happens here is I'm just defining some colors, basically saying, okay, our first group is going to be red, our second group is going to be blue, our third group is going to be green, and our fourth group is going to be yellow. So this reason why we put these different colors is so we can identify it. Just like how we have, essentially, you can imagine like this group being one, this group being one, this group being another one, and we're coloring it so that we can more easily detect what those groups are supposed to look like. So I have these different colors, and basically I make this function, which again comes from the curriculum. But basically I'll take in data X, data Y, which I'll generate, okay? And basically I'm just gonna color it. So this just allows us to check out what data we generate. So right here, this is our actual generation. This is going to use sklearn data sets samples generator, okay? So this is our whole library right here, okay? And we're gonna import make blobs. So make blobs essentially will allow us to make, different data sets, and we can pass in parameters. For example, I can create 100 samples, centers of 4 basically are saying that, what's it called? You are saying how many different groupings you can have, and the number of features where you might have multiple features affecting your setting. So, and you can look at this. Let's see if I do this XY now. You can see here this plot. Oh, did I not? Oops, I didn't import this part. Okay, let's try to run that now. There we go. So you can see here is that this is data I generated randomly. And you can see here is that all this function did is basically just plotted out for me. So it's plotting out all of the ones that are from that one group green, second group yellow, fourth group red, and third group red, and fourth group blue. Okay, so you can see the different parts. And if I run this again, you'll see that it's a different, they look different each time. Okay, so you can see basically it's randomly generated. And you can see 100 samples. For example, I could put like 1,000 and you can see a little more data set that's more clustered around here and stuff. So this is a really quick way to basically generate data. In this case, more clusters around here, and you can see different features, basically saying like this XY kind of deal. So for example, I can possibly do, I think hopefully this will break. I can do 3 centers where it really should be 3 groups. And you can see here is that there's only 3 groups that are actually being generated versus 4 groups. I think if I try doing 5 groups, this is not going to work because my function can't handle that. You can see it can't handle the 5th one. So I'd have to readjust this plotting part, but I could generate this data however I want. So yeah. Okay, so that's kind of like making some blobs right here. Sorry, I'm looking at this real quick. Something else looks wrong. Is this wrong? Okay, sorry, I got distracted, but now I'm on, okay, there. I got concerned, like, where did my code go? It's down here. So this is one set like that clustering. They call make blobs. We can also do something similar called make moons. So the moons you'll see are kind of like these kind of crescent shapes that are wrapped around each other. So you can see here, this is creating that different moon shape. And you can see here, like you saw, this is that moon, the different algorithms don't classify as well, depending on the moons. You can also give it, like, you'll notice this noise part. So you can, for example, give it like a lot more noise. So, and you'll see here that the data will be not as clear that it's supposed to be a moon shape. But if you kind of knew, you can kind of see there's a general moon shape here. There seems to be a little overlap in different spots. I can also put in a lot less noise, and you can see that this will create more of a moon shape right here. There's almost no noise at all. So this is where I'm talking about. You have to decide what, essentially it's more realistic data. You can see here it's a little bit more. I'm surprised actually how much that changes. And you can see here more of a moon shape, but not exactly right. So there's different parameters, and you can see here like make moons. You can see there's shuffle, true, noise. I can't see that very well. Random states. You can make sure that you have this. And this is really useful again for clustering, where you might have something you want it to find these different groups, and different machine learning algorithms will do a different job, good enough job or bad enough job or bad job on finding these patterns. So this is why you might want to pass this stuff in. Okay, and it's a lot cheaper than actually trying to get real data, because you can generate as much data as you want. Like I said, you can put like 10,000 in here, and like I do more of a noise. Okay, I want it to be more noisy because I found that the data in real life is a little more noisy. You can see this overlap going on here. Okay, cool. So that's make moons. Make circles is like the concentric circles. So here, for example, I have the noise. I can do the number of samples, and you can see here when I plot it, you can see here I have this, right? So you can adjust these samples. And again, it's just sample data set, so we can test out our different algorithms and having it through without having to get real data and stuff like this. Okay. And then of course we also have like regression lines. So this is like if we have data that should be along a regressional line, we can actually create this. And I believe this will work fine. In this case, I only have one feature. You can see my noise right here. I also adjusted the alpha for plotting. And part of the reason why I did that alpha is basically so you can see it better. If I actually set this to 1, which is the default, you'll see that they're all lie on top of each other, which is a lot harder to see. So I like to put in a little bit of alpha. For example, if I put 0.03, that basically is saying for if there's 3 points on top of it, it'll equal 1. So if I do less of this, this might be a little bit easier to see. Oops, 10's too small. Okay, so you see right here is that data is kind of generated around there. And you can add more or less noise. So for example, put 1. You can see here, basically it's on the whole line. So this could be useful, like testing out, like again, your regression lines, like, okay, this is my, my line, and quickly generating information. You could do this yourself, but sklearn has a lot of really easy ways to do this. And I think you can put in multiple features. Oh no, because I think I have an issue with, yeah, the problem is that I'm only plotting X and Y, so I think I would have to go. No. Let's see if I can do this real quick. So you can see here, this is Y. Let's see the length at Y. 100, length of X, 100. Let's see what X's look like. Sorry. Okay, that's why. Oh, I'm dumb. Because Y is our dependent variable. That's why I named it Y. So you can see here. So this has two features. So for example, if I do X, it should be 0. Oh, but it's going to be, this is why I don't like doing live programming a lot. There we go. So you can see here, that's my first feature. So I have, let's say if I have one feature here, I'm going to give, let's do 1,000 samples because it's a little bit easier to see. Oops. So I have different features here. So I have my first feature, X0. You can see here it's randomly generated, but I can also have X1. And it's probably gonna look very similar, but you can see here is that they're slightly different now. So this is the way you can kind of like generate multiple features, like that different feature data and different noise levels and stuff. Okay, so again, quick way to test your model. And you can see here is that if you want, it's like, well, what if I don't want my data to be in a line format? It's like, well, you can actually take the data and adjust it. So in this case, I'm going to keep it with just one feature because I think that will break the way I have it set up right now. So I can take the data from Y and basically square it. So I can have a parabola or what's it called? A cubic function, right? So you can see here, I kind of have this cubic function and I can again add in extra noise. So if I do like 15, you can see that's what, now of course I have this wrong, but you can see plot and it was X, Y. Okay, and you can see here, that's my data. That's the original data, and I just transformed this to make it so I now have a parabola or a cubic function. And this allows us to kind of generate that data that might not be a nice line, for example. Okay, cool. Any questions on generating this data? Okay, cool, yeah. And again, this is useful when you're testing out multiple models and seeing, you know, how well it does on certain data sets that might have it. And you might pick these specific ones because you expect your data to have a certain shape to it. So this is why you decide that part. Okay.